Okay, back to simplifying again and a little bit of multiplying and dividing rational expressions. I'm going to still kind of stick with the fraction theme, but if I wanted to simplify a fraction of 2/5, I'm going to really think about it as this being, this 2/5 as what can I divide both the top of the fraction by and the bottom of the fraction by. Or in other words, I'm going to write it out as factors. So like 2 is 2 times 1. 10 is 5 times 2. Cancel out the 2's, and I'm left with a 1 over 5. Okay, similar concept here. I have 4 times 4 gets me 16. 4 times 3 gets me 12. Cancel out the 4's, and I'm left with 4/3. Now, 15 and 11 aren't divisible by anything, so therefore I'm not going to reduce it in any way. It's not like I can go 11 plus 4 over 11 and cancel out 11. No, don't ever do that. We're only canceling out things over multiplication. So the idea is that if I've got a factor on the top and the bottom, and some of these might look familiar because we've done it before, but I'm going to take out a greatest common factor of 4x, and I'm left with x squared plus 3. Okay, and this is 4x times x, so I'll take out factors of 4x's, and I'm left with x over x squared plus 3. I'm not going to cancel out these x's right there because that is addition, not multiplication. I can't cancel out over addition. So here again, I'm going to factor the numerator, x minus 6 and x plus 1. The denominator, x minus 1, x plus 1. The top one I did by trial and error. The bottom one I did by the difference of two squares. The x plus 1's cancel out, and I'm left with x minus 6 over x minus 1. Okay, well, when it comes to multiplying fractions, what I can do, not only, like if I have 5 over 10 times, let's go 25 and 2. Not only can I reduce up and down, so I can take a 5 out of both of these, I can also reduce diagonally. So 1 times 1 is 1. 1 times 25 is 25. I get 1/25. So this first fraction, I'm going to reduce it as much as I can. So 6 and 2 is going to be 3. X squared divided by x squared is 1. Y to the third divided by y to the second is y to the first. So on the top of this fraction, I've got 3y over 1. Okay, 10 and 18 are both divisible by 2, so 5 over 9. So I've got a 5 and a 9 left over. X to the third. And if I take y to the second from the bottom, y to the second from the top, I'm left with y to the second on the top. Okay, now diagonally I can also reduce. I notice that 3 and 9 are both divisible by 3, so there's a 1 and there's a 3. So as I multiply my numerators, I've got 5x to the third, y to the first times y to the second is y to the third, all over 1 times 3, or 3. Now, to make this a little bit nicer, what I'm going to do again in this polynomials below is I'm going to factor my polynomials first. So here my top one here has got a greatest common factor of 3x. So there's 1 left over minus 9x squared. Okay, I'm going to erase my work from above because I need the room. Okay, but you've got it on the video here. You can see it again. You can rewind it again if you want. This is the difference of two squares, so this is going to be 1 minus 3x and 1 plus 3x. Now, I got that 3x from before, and I kind of like to cross out the answer from above so I don't get kind of confused. So now when it comes to the bottom, I'm going to try to get one of my top two things. So I'm going to try 3x and x. I'm going to go plus 1 and minus 1. Do a little foiling, and it works out to be a negative 2x with those O and the I. And the reason why I picked those two is, check this out. I've got the 3x plus 1 and the 1 plus 3x. They're the exact same thing. They're going to cross out. Okay. So here again, I'll go 3x. Oh, don't want to write that parentheses right there. Sorry. So I got 3x, and x will give me 3x squared. And the factors of this are going to be of positive 1, so I'll go minus 1 and minus 1. Which again, if I FOIL it out and check it out, it works out to be that. When it comes to crossing things out now, look at diagonally, I have an x minus 1 and an x minus 1. They're gone. I've got 3x and 3x. So on my numerator, I've got this piece and this piece. So 1 minus 3x and 3x minus 1 all over 1, or just leave it like this. And I'm okay with you leaving it as a factored form. You don't need to multiply that out. If you want, you can go right ahead, but I'm okay with that. Okay, if I'm ever to multiply a fraction times a whole number, so like 5 over 3 times 6, I'm going to make that whole number over 1, so I'll take this polynomial over 1. Here's x plus 2, and this is a binomial, but it's not the difference of 2 squares, it's the difference of 2 cubes. Okay, I'm sorry about that. What cube gets me 27? Well, 3x and 2. And if you don't quite remember the pattern, remember the goal is to try to cancel out either vertically on the fractions or diagonally. So since this is 9x squared minus 6x plus 4, I'm going to guess that that's probably 9x squared minus 6x plus 4 as well. And it is, because 3x to the second power is 9x squared, 2 squared is 4, and 3x times 2 is 6x. So this leaves me with 3x plus 2. Cancel those out, and I'm left with x plus 2 over 3x plus 2. There you go. Okay, dividing fractions. So if I've got 3 halves divided by 2, fifths, it is to multiply by the reciprocal. So this becomes multiplication. This flips around and becomes 5 halves. So this is going to flip around and become multiplication. And then I'm going to factor from there. So a little shortcut, I'll factor out a 4 here, x minus 2. Factor out an x from here, x plus 3. So I'm going to try to get this x squared plus x minus 6 to factor into one of these two things. And I think I'm going to be able to get it to be x minus 2 and x plus 3. Which is, let's see, I don't know if that's, yep, that will give me positive x, which is nice because, again, diagonally and vertically, so up and down, x minus 2's, diagonally, x minus 2's would cancel out. And vertically, the x plus 3's would cancel out. So on the top, I'm left with a 3, and on the bottom, I'm left with a 4 and an x, so 3 over 4x. Okay, same thing here. When I'm dividing by a whole number, it's going to turn into multiplying. And whenever you have a fraction that's a whole number, not a fraction, but rather a whole number, make it over 1. So we'll go 8x plus 10x minus 3 over 4x squared times 1 over 4x squared minus x. So take out the greatest common factor. Okay, that's going to replace that, and again, I'm going to use that as a clue. Then I'm going to think of 8x squared as 4x times 2x. I'm going to try for minus 1, and that leaves me with a plus 3. Do a little foiling, yep, 12x minus 2x gives me 10x, so that's cancel out right there. So again, I go through and I go up vertically, nothing to cancel out, but diagonally I do. I've got here and here. So on the top, I'm left with 2x plus 3. And then on the bottom, I got 4x squared times x, so 4x to the third. So that is multiplying and dividing fractions. Again, rational just means fractions, so all your rules to multiplying fractions and dividing fractions are the exact same things. You just have to make sure that you factor first before you decide anything.